Good afternoon, everyone, and welcome to Improving's Virtual Lunch and Learn. Before we get started, I wanted to inform you about a feature that'll make the session more interactive. Please take note of the question mark icon that's in the upper right-hand corner of the presentation. If you click that icon, it'll open up the question and answer feature, which will allow you to send our moderator a question that can be delivered to the presenter at an appropriate time. We encourage you to enter questions at any time. We are excited to have Tim Rayburn, VP of Consulting with Improving, who will be sharing with us Enterprise Service Bus 101 MassTransit. Tim, the floor is yours.
Thank you very much, Max. Thank you very much, everyone, for taking your time out of your lunch today to come join for this session. I know how much of a premium time away is, and so hopefully we'll give you something to really learn and to have usefulness for you in your day-to-day job. So a little bit about me. I am, as was mentioned, a vice president of consulting with Improving. I've been doing large computer systems, talking to other large computer systems for pretty much my entire life. I've done it in healthcare as well as in the broader insurance arenas. I have done it for e-commerce solutions and warehousing solutions and supply chain solutions. Basically, I've spent a huge amount of my career working in this space and understanding what it's like to have large systems talk. And today is going to be a one-on-one introduction to one of the primary patterns that we'll see, why we use it, etc. And so this is just a little bit about me. I'm definitely a big geek when it comes to things like board games, card games, and things like that. And if any of this interests you, feel free to reach out to me on Twitter or otherwise. I am certainly available and happy to chat with people. So let's get into just a quick plug here. Improving is hiring in this time, even though most other places aren't. So if you're in a IT-related field, maybe you're a modern workplace expert, maybe you're a .NET dev, maybe you're a Java dev, we'd love to hear from you. We have jobs all across the country, as well as in Mexico and Canada at the current time. This is the place to go find all of that. So feel free to jump in. Okay, so let's talk about what an enterprise service bus is. What is an ESB? This magic set of acronyms that architects everywhere just think immediately solve all your woes, and they don't. But an ESB is several things. If you listen to the big players in the market, be it IBM, Microsoft, etc., this is an excellent way to give them thousands on thousands to millions and millions of dollars and have them interact and give you software that you can run that you may not have any idea of the underlying principles of, but CIO magazine has spent years telling people they need enterprise service buses, and so this is one of these things. What we're going to answer today is, what problem does it actually solve? What are we trying to deal with? And how do we appropriately use an ESB? So in particular today, just at the outset, when we get to the demo, we're going to talk about an enterprise service bus using an open source package called MassTransit. It is a fantastic piece of software. I recommend it regularly to my clients. I think that if you're looking for a way to step into the world of having an enterprise service bus and aren't interested in paying 6+ digits to a major software vendor for really what at the end of the day is a set of architectural patterns more than it is anything else, then MassTransit is the way to go about that for you. And so I would strongly encourage you to make that your entry point if you are wandering into this space for the first time. So there's a wonderful book by Greg R. Hope and Bobby Wolf that describes a message bus this way. It says that a message bus is a combination of a common data model and a command set and infrastructure that allows systems to communicate through these shared set of interfaces, much like the bus that is used to allow a CPU to talk with main memory and its peripherals inside of a computer. Very similar structure, just brought from the hardware level up and raised up into a higher level of abstraction of allowing independent systems to coordinate with each other this way. And I will tell you, after having spent years writing software, the number of times you will run into this exact thing where we have a principle that works at one level, and we're simply going to raise it up and reuse that same concept is shockingly useful. One of the favorites of everyone when we're talking about object-oriented design is that we should have the single responsibility principle, that a class should have a single reason to change, right? I also think this is a fine thing to be said about a system or a service as a whole, is that a system or a service as a whole should have a singular reason to change. And that concept at its heart is what's behind microservices and this concept of build in the small and build changeable units that can interact. That entire world is driven by this concept of SRP, that single responsibility principle, taken up a level. It's just the definition of what can be our one reason to change is allowed to be somewhat bigger than it is at a class level. So this is what a bus does for us. Now, as I mentioned, this comes from a book. Go get this book. If you do nothing else from this talk, go buy this book and read it. Gregor Hope and Bobby Wolf. It is an absolutely go-to reference for me when dealing with large system integrations. And if you can learn so much about how systems interact and the solid patterns that are used in those simply by giving a read through these patterns in this book. This is I've literally recommended this book to my current client this week. It is a fantastic resource, and I strongly encourage you to check it out. So synchronicity. This statement, it's slow and wasteful. Well, why is synchronous slow and wasteful? Why is it that we believe that it is a bad idea for computers to do work in a synchronous fashion? Well, that's fairly simple to explain. It comes down to, how do you want your system to fail? Because any system can fail. How do you want it to fail in the long run? Do you want it to fail in ice or in fire? So the death by coupling is the death of ice. When we have a system that is highly coupled, that every molecule is tightly connected to another molecule and everything is exactly in structure, you wind up with something like ice, a crystalline structure that is very brittle, right? Is prone to shattering, okay? And so you wind up in this place where I am directly aware of how, who and what is doing the work that I want done. And while that may sound like a good idea, it really winds up being an immense bottleneck. So just to give an example here, I'm gonna drop my cam and let's walk through this sort of basic walk of a synchronous workflow. I have a user on the left, and they're gonna pick up some data, and they need to give it over to a clerk, and the clerk needs to put that away and then generate a receipt. That receipt then needs to be given back to the customer in question, and the customer needs to put away the receipt. And there's a large amount of this data that needs to be given to the clerk. But this interaction right here, where we hand off data, and then we're waiting for the receipt to be generated and for the receipt to be transmitted back to us. What's happening with our customer while the clerk is doing this work? The answer is absolutely nothing. This work is being done and our customer is blocked. They're simply waiting. They can't go to the lunchroom and grab a Coke. They can't do anything. They are absolutely at a standstill because they are in asynchronous communications with the clerk in this case. This is a singular point of coupling, but when we expand this in a system to start saying, I have one service and it depends on another service, and I'm going to block and wait. I now have a thread or a CPU waiting around for another computer to complete its job. And then, moreover, if I also then need to go on and send something on to someone else, even if it's not directly related to it, even if I could do that work while this person was perfectly capable, while this clerk was working, I could go talk to a completely different clerk and deal with them and give them something else. I'm blocked because I'm waiting for them. This synchronous communication both is a horrible performance lag and is an example of a tight coupling. I know that I need to talk to this clerk, that this clerk needs to do the work. I don't have any freedom to simply say this work needs to get done, and when it is complete, get back with me with a receipt. That structure is denied to me via this synchronous communication scheme. So if we're not going for this, if this is ice and we could die this way, which is we freeze and nothing moves, as slowly over time systems get larger and larger and we have more and more and more coupling, it becomes impossible to reasonably respond to change, to respond to new business demands. Your system becomes too big and too heavy to make alterations to, because a change in one place will now ripple and wind up affecting the whole system because of I changed X, which I changed service X, which changed service Y. Well, service Y is used by service Z, etc. And very suddenly these ripples start playing out, and you see a huge amount of change for even the smallest amount of new business value. So the death of activity is the death of fire. So this one is mitigated somewhat from when I first gave this talk, over 5 years ago. Now, as we start getting an ability to truly scale up in response to activity, but really is speaking to the concept that if we're not going to be tightly coupled, we do run the risk of operating so quickly with so much demand that we're just under constant bombardment. And this is good and bad. There is absolutely such a thing as too fast. And it is a thing to keep in mind when you're looking at how much horsepower you're going to be throwing at things. But we're going to just simply walk through. This is a very similar example to the one we had previously, except now we have 4 customers. And in addition to those 4, but with those 4 customers, we still only have 1 clerk that's working. And so, but in between them, we've created a bus. We've created a enterprise service bus, in this case, that is going to decouple the producers, the customers, from the clerk, who is our consumer, in this case, of messages off the bus. So our customers are all going to pick up some work to do, and the customers are all going to put that out onto the bus. They have no idea who is going to service that. They have a strong hope that it is serviced, but they are simply putting it out onto the bus saying, here is data, someone should be interested in this data. Then when that happens, they go and say, hey, we're trying to get all of this data processed. So why don't we go pick up the next set of data? So they all pick up more data and prepare to put it on the bus. And the clerk picks off the first piece of data from the bus and goes, oh, hey, I have a piece of data that I need to process. So that first piece of data gets put into storage and a receipt comes back. And then pardon me, going the wrong way. And then the customers all put their data onto the bus for the second set of data, and you'll see that the receipt is put onto the bus. Now, in the meantime, our worker has also picked up its next set of data to be able to put it away. And so what happens now is one of those customers now picks up their receipt going, oh, hey, I have a receipt here that says I'm interested. This is the receipt that my original work, my round one work, has been completed. And then likewise, we are seeing the last piece of data get picked up by one of our customers. The other two customers don't have any more data to give. There's no more data in the pile, so they're stuck where they are. And our worker has produced yet another receipt because he's put away yet another piece of data into the storage area. And so now that receipt will be put onto the bus. The receipt from customer one will be put down where the customer puts away their receipts. And likewise, we continue processing. So a couple of things to call out here that are super important. The customers have no idea who's working these items. They do not know if there's one of them or 50 of them. I think anybody who has placed an order for a in-demand item, take your pick, the newest iPhone, the newest Android device are easy examples that come to mind, has experienced the concept of we're all in a rush to go do a thing. Everybody's trying to do it all at once, and I'm not exactly sure where I was in the line. I'll find out, do I get it on release day? Am I going to get shipped on release day, or am I going to be followed on after that because of the fact that demand exceeded capacity? But that fire, that immediate activity, has allowed us to build up this work yet to be done. Things that are on the bus in this case, and to be clear, they will not be amorphously in memory or someplace. We'll show you the exact technologies that we're going to use for this in a moment. But items that are on the bus that need to be worked, those items absolutely are durably stored, but not yet worked, right? They are not actually being worked. Now, individual items are taken off on a one-by-one basis to be able to work them. And so that allows our singular worker to just chug along and do his job and always have a bunch of work to do, keep him very, very busy. If he is outnumbered, as it is in this case, on a regular basis, then maybe having one worker only is a bad idea. If, on the other hand, what I just described, where there was a bunch of data and it was going to be dumped onto the bus by a bunch of our customers, but then they ran out of data because maybe this is, hey, this is the morning report on what the weather is in all the weather stations around the world at 6 o'clock UTC. Well, every weather station is going to produce their output, but really, they're not going to do that every single minute of every single day. So I don't necessarily need as many workers as I have the producers in this case, and the customers in this case. Those customers that are producing messages onto the bus, they absolutely can outnumber, and then the worker will simply get caught up in the fullness of time. So when we're talking about a bus and what we're going to get from it for us, we're going to see a handful of things that are key here. The first of which is that we want to have asynchronous messaging. We want to be able to turn work over to the bus, and then forget it. Go about our business, be idle if we need to, but not be synchronously bound to communication. So we need asynchronous messaging. We need consumers, the workers in the example that I had above, we need them to be able to be independent, that they can work and there can be as many or as few of them as there needs to be. We do not want them to be tied to the number of people producing onto the bus. That side is completely under its own control and independent when it comes to scale. We want to be able to put things onto the bus. The messages that we put onto the bus, we want to be descriptive enough that that work can actually be done. If the first thing I get is I receive a message from the bus and the first thing I have to do is go call the person who gave me the message immediately because of the fact that I'm like, oh, I don't have enough data here, then you also have a failure, okay? So this need for descriptive messages. And then we need to have an understanding of the broader system contracts, which is to say, I need to have an expectation that particular consumers, particular people who are consuming messages off the bus will have expected returns. So it's very, very bad idea to say, I'm going to put something out onto the bus and then I get no acknowledgement that it's coming back. I may not need the acknowledgement, but there should be an acknowledgement that that is being produced back just in case. That simplistic mindset of I should produce some sort of outcome regardless of the type of outcome I have. So if I consume a message and the message causes me to throw an exception and my code explodes, then I should do my darndest to make sure that I communicate back to the bus that I've had a failure and here's an acknowledgement that I failed to process that message. That failure should go out unless the cause for everything is something more infrastructure, like I've lost contact with the bus, etc. We want to know that given input, I'm going to have a certain set of expected returns. It may not always be the success criteria. You need to absolutely think about those failure scenarios as well. So I'm about to jump into code and let us actually see how we would wire some of this up inside of MassTransit. But before we get there, I wanted to ask, do we have any questions from the participants?
We don't actually have any questions at this time, Tim.
All right. Well, I'll have another spot after the code demo where I again pause for questions. So if you have any, please remember that the Q&A feature does exist and you are welcome to use it to ask me any questions. So let's jump over to the demo and find ourselves inside Visual Studio. All right. So this is a starter solution, the code of which will be available when we're done with this. I already have it checked into a GitHub repo, and we'll check in any changes we make during the course of the presentation, because we probably will when I am done here today. So this first example that I have for the Easy ESB starts with a simple console application written in .NET Core. And all I'm going to do here is lines 13 through 16 are simply doing two things. They're setting up a dependency injection container for me using Microsoft's dependency injection container. And they're setting up a logger so that we have an ability to log and get an understanding of what's going on inside our code. Lines 18 and 19 are getting a logger and then getting the actual code that we'll be running here, which is called MassTransit service. And then we simply log that we're starting. We go and tell the service to go run, and then we log that we are stopping the application. This await is a blocking call. As you will see here in a moment, we reach a point where we pause for input. And so we will not immediately go from this to this. You will hang in the middle of this line 21. So I'm not going to spend much time reviewing, and this structure is the same for every one of the console applications that we're running today. They will log that they're starting, run a thing, and log that they're ending. I simply wanted to acknowledge there is a dependency injection structure being used here. There is a logger, and at the current time, that logger is set to log info messages only, so we're not seeing trace level details of everything that's going on. So, with that said, let's look at this. Now, this MassTransit service is meant to replicate our customers in the demo that I walked you through in the slides. They are going to come in, and when they run, they're going to tell MassTransit that there is a logger that it can use, and then it's going to ask MassTransit to create a bus using RabbitMQ and point it to a locally hosted RabbitMQ. I'm simply running a Docker container that allows me to instantly have a RabbitMQ installed. Rabbit is a message queuing infrastructure. It is open source. It is fantastic. You should never, ever, ever use MSMQ. You should use RabbitMQ. And for the details of why of that, get with me some other time. But if you have not personally had the woeful experience of using MSMQ, just trust me, Rabbit's a better choice. Now, we're then simply going to come in and tell the bus to start. Please start, and it is an asynchronous call, so we await the results. And after it is started, I'm going to loop 10 times, telling the bus that I wish to publish a new message. Now, message is simply to be clear that this is what we're doing here. Let me show you what message is. Message is a class that has an ID and a string of text and nothing else. It is simply a class. So I'm going to initialize that with a new ID and make the text message that this is the message and include the ID in that message. And we're going to ask the bus to publish this out. So please note, all I've told this system is where the bus is. I have not told it anywhere where the consumers of these messages are. I'm simply saying, connecting to the bus and saying, I would like to send this message, publish this message onto the bus. That's all we're doing. And then I write that we can press any key to exit, and then I await the possibility that somebody has pressed a key at the console. So before I run this, and I am about to run this, let's go look at what the dashboard for RabbitMQ looks like when you have a fresh install of RabbitMQ. So we'll come here. This is the RabbitMQ Web Management Dashboard. And a couple of things to call out here. This is the overview page. And in here, it shows me the message rates, the rate at which it is receiving new messages. And you will see that right now it is receiving no messages. It also shows me the number of messages it has queued. And you will see we also currently have 0 queued messages. So these, I'm going to go to exchanges. Exchanges are a way that RabbitMQ handles the pattern of publish and subscribe, the ability to have a message come in one location and then fan out to multiple other locations. Now, these exchanges that exist right now, you'll simply have to trust me if you've never seen Rabbit before, but these are here by default. Okay, there is nothing here that has been configured for our code. And likewise, exchanges eventually deliver to queues, and there are no queues in this install at the current time. We have created 0 queues for the current time. Basically, this is in fact a RabbitMQ that has just been warmed up for the very first time. It is utterly empty. It has seen 0 business, 0 work done on it. So I bring that up because we're about to flip back to our code, and we're going to go ahead and run this service, the ESB Service. And so let's go ahead and kick this off. And I'm simply going to run this once. Okay. And I forgot to change the properties on this font. So let me make that a little bit bigger and easier for everybody to read. There we go. All right. So we've indicated it via our logging that we're starting the application, and we've reached the point where we say press any key to exit. That means we have published all those messages. If I flip back to RabbitMQ, I see that we have this peak a few moments ago where we received a large number of messages, about 2 messages per second across a time period, because we published 10 messages. But you'll notice we have nothing queued. Now, this is how MassTransit has been set up. So several things happened during that start async that are worthy of mentioning. When we came out and said, hey, we're going to publish a message called the ESB message. And when we did so, an exchange got created for that message that is typed to the message. This is the namespace and class of that message. Now, this the bindings on this exchange say it doesn't actually go anywhere. There are no queues that exchange is delivering to. This is, I published something, but there was no one listening on the bus. And so the bytes went up, they got delivered to the bus, and they disappeared into ether because no one had ever told the bus that they were interested in consuming those messages. So likewise, still no queues created because of that. So let's jump back to our code. Let's go ahead and end that process. And we jump back to Visual Studio. So we have seen that our producer can warm up. It can send messages to the bus, which is good. We saw that it did send on the dashboard, but we haven't had anybody consume yet. So I'm going to switch and run the consumer now. Now, the consumer MassTransit service looks very, very similar. It also has a connection to the local host, RabbitMQ. It is also going to start async here. And the difference is this consumer has an endpoint in it that says, I would like to receive into a message called test queue, and I would like to handle messages of the type the ESB message. When I receive those, I'm going to get the message and be able to receive the text out of that message, and I'm just going to do a console write line of that message. So I'm simply going to output to the console that that I received this message. So if I warm up this process at the current time, we once again are up and running. But at this point, if we flip back to the dashboard, you will see I now have a queue that has been created called test queue. And that exchange that had previously been created, that was the ESB message, now has a binding that sends the messages of that type into the test queue. Now, if you're sitting there going, oh, so I always have to warm up my publishers because they're going to create the exchange, and then I have to warm up my consumers because they'll create the queues. Nope, no such binding exists. So what I'm going to do now is end my consumer, and I'm going to come back here. And very quickly, I'm going to delete what just got created. I'm going to delete this exchange for the message type. I'm going to delete the exchange that got created for our queue called test queue. And then I'm going to delete the queue itself. So we're back to 0 queues, nothing in exchanges except the AMQ exchanges that are automatically there. And as soon as I do that, I'm now going to jump back to Visual Studio, and we're going to run this process one more time. Now, the consumer knows that they want to receive. They know the type they want to receive. They actually, on the consumption side, have all the details. And so if a consumer comes up first, then that consumer can completely configure things. So now we have this exchange again, where we bind the easy ESB message to go to this test queue exchange. Test queue exchange is bound to the actual test queue here. And you'll note that it knows that upline from it is the easy ESB message. And then we have our actual queue here. All right, so just warming up a consumer completely configures its subscription, and it is up and running. Now, the important thing to note here is the consumer does not have to be up to be receiving messages. Once its subscriptions have been recorded into RabbitMQ via MassTransit, MassTransit did all that work for you, created all those subscriptions for you. The moment that that is done, I can switch back, and at this point, I can run our producer here and run the easy ESB portion, and then we can come back to the dashboard here, and we will see that this has in fact produced a set of messages. We had them come in, and that now those messages are sitting in a queue. Those 10 messages that I produced are now sitting in the queue waiting, because they were received into this easy ESB message, sent to this fan out queue, and that fan out exchange, and this has in turn delivered it to this queue. And this queue now has 10 messages sitting. Our consumer is offline, so the work is just sitting there waiting for them. Our producer here can end and shut down its process, go away. This work is still waiting for it in its inbound queue because the bus was aware of its subscription. And so maybe it's been running this whole time. Maybe we're just warming it up for the first time, but we're just going to go ahead and spin up an instance of this process. And all of a sudden, it's going to receive all 10 of those messages that it had put away for it on the bus, and they are going to be consumed like so. Now, again, benefits, this is not simply a queuing solution. It is built on top of a queuing solution, but it is important to note that nowhere in here, again, was the producer tied in any way to the consumer. And in point of fact, we're going to prove that by coming back to our producer process, and we are going to produce a lot more messages. So let's produce 1,000 of these messages. Actually, let's go ahead and produce 10,000 of these messages. I'm feeling crazy today. And we're going to fire this up. We'll have a little bit of a delay as all 10,000 of those messages get sent over to our Rabbit instance. And then if we switch over to our Rabbit dashboard, we should start seeing a large number of messages coming through. Now, the dashboard is currently set to refresh every 5 seconds, so don't think that it's being super slow. We're only asking for an update every so often. And we're producing it at a clip of about 60 per second, so it'll take us a little while to get through. I don't have a lot of horsepower assigned to this Rabbit instance, and I am awaiting every send on the .NET side, so I'm using no ability to work in parallel here. I am sending one, waiting for it to finish, sending the next one, waiting for it to finish, etc. But we're going to get to the point where we have a large number of these messages running. So let's go ahead and spin up our consumers. So I'm going to go ahead and say, hey, I would like a new instance of the consumer of these messages. And all of a sudden, it's draining off those messages like wildfire. The Rabbit dashboard will now start showing that our queued messages are going to probably start actively declining, because in this particular case, since we're just writing a console message, we're doing almost no computational work while pulling messages off. So despite queuing for 10,000 messages to go on this bus, we are exceeding the speed at which we can add things to the bus by how fast we're pulling them off with just one of these consumers. So this, our big fonted guy, is still trying to send and get to 10,000 messages sent, but our consumer is just draining out the work and basically never has any significant amount of work waiting. It is consuming every message as it's dropped in. Okay. So let's see if we can get it to the point where we can overload our singular consumer here in the background. Okay. So we're going to go back to Visual Studio. We're going to go back to the Easy ESB, and I'm going to tell it that I want another instance of that. So I've just started up a second producer. So I'm producing yet more messages. I now have two processes trying to send 10,000 messages. Oh, the first one ended. Let's go ahead and get a second one actually running, because 10,000 is not infinite. So let's warm up that second instance. Okay, there we go. So we have that one sending and that one sending. This guy consuming like crazy. And if we go over here, yep, we are producing over 100 a second and climbing. And still at this rate, we're really not to the point where we're producing enough for this very lightweight consumer who's doing nothing but log a GUID to the console to be able to get there. Oh no, there we go. It's getting a little overwhelmed now. There are a couple of queue messages, but it's like, that's like, ooh, we hit a 5-second interval where there was one message waiting. Let's see if we can, what happens when we add a third producer to the mix. So we now have a third producer. So we have 1, 2, 3. Oop, that's not producer. So there we go. 1, 2, 3. Our singular consumer. And if we go back to Rabbit, okay, now 3 going on at once. We are hitting a more regular pace at which we're exceeding the capabilities. I don't think any of these have stopped yet. So yeah, they're all still chugging along trying to send their 10,000. So yeah, we're occasionally building up 2 or 3 messages in that queue. So all of this is to simply show that we were able to scale up the number of people producing messages. No need to change the consumption side for a super lightweight consumer, but also importantly, again, no awareness of where each other are. All they share is the contract for what that message is supposed to look like, and that they are both talking to the same bus. So they talk to the middleman, and that bus handles things. Now, some things I want to call out as we start moving towards the end of our talk here as about this process is nowhere in here did I say, and now we started a mass transit service. The only long-running process that is being used in this case is Rabbit. RabbitMQ handles the storage for all of this, because it is all of our publications and subscriptions are stored in the exchanges of RabbitMQ. So we're not having to deploy and run services on our box. We simply have to have RabbitMQ available on our network, and this will keep us up and running. Now, There are absolutely more advanced scenarios where you might have actual long-running processes that are related to running the bus. If you are running Saga workflows, if you're running timed events where you need something to be sent to the bus and then not be delivered for some time, there may be examples of that. It looks like we have finished producing messages on all our producers. So first process is done, second process is done, and the third process is done. And then finally, our consumer is done. So the only thing you had to run to get this running was RabbitMQ. RabbitMQ is open source software, heavily supported open source software. And so you can get commercial support licenses for Rabbit if you want to, but this is in and of itself a very proven technology. And what MassTransit gives you is a set of libraries for working with this in .NET that get you out of managing the creation of exchanges and queues. Those exchanges and queues that made that example run were entirely created by our code. It was all done because of the fact that we configured MassTransit to be aware of what our subscriptions were. So this is the example of a subscription. And then that subscription, when we went to start async, part of what MassTransit does is confirm that that subscription is properly represented in the exchanges on your bus and inside your Rabbit instance. So I like to say this is a bus without a running service. All it has is the transport mechanism, and it uses that transport mechanism when it is Rabbit. That MassTransit uses it to its greatest effect to keep very light its implementation for you. You just bring in some NuGet packages to use this. All you need to do is grab this MassTransit RabbitMQ package and add it in. Every other NuGet that I have in this package is, dependency injection from Microsoft, MassTransit's extensions for that dependency injection, and then the logging, console logging library from Microsoft. Now, this is an introductory talk, so some things I want to mention. You will almost certainly never create a subscription this way in your actual code. This is a very lightweight way to say, let me create a handler for a message directly on a inside of a Lambda, and it's useful for demos, but you are much more likely to create this as a class that you can then register with your container, and then your code will automatically pick up all of those pieces once you have got MassTransit connected to your container. All of the consumers, as they're called inside of MassTransit, all those consumers will automatically be registered into MassTransit. It will pull them all in and interrogate them for their implied subscriptions and take care of that for you. What does that look like? That a consumer looks very similar. It's the My Consumer here, and we are simply going to go to MassTransit, and we are going to create an iConsumer of a particular message, and in this case, we'll make that message named message. Okay, and we are simply going to implement that interface. That interface looks identical to this. This Lambda takes in a consume context. So this body here is literally the body of your consumer up here, like so. And it returns out a task, which is why we're using the right line async here. And this consumer is the equivalent of these 3 lines of code or 4 lines of code here, 33 through 36. The receive endpoint, as far as which queue, would continue to live here, and we would simply load we would tell that that we wish to get configure its consumers from a container, okay, and that would be, and we would be off and running at the races. So simply to say that lest you go, oh, well, I don't want all my consumption code in Lambdas, that's not what you would be having at all. So let's shift over and see if there are any questions as we come back out of the demo.
Yeah, Tim, we do have a few questions here. I'm going to actually combine a couple of them because they're very similar. But the first one was, what are your thoughts on using open source technologies like RabbitMQ versus a vendor solution like Azure Service Bus?
So to be clear, I think that that's not an or solution, but I will say that I'm a fan of using the right tool for the right job. And MassTransit, the example I gave to you today was MassTransit backed by RabbitMQ, but the Azure Service Bus is again a very useful technology when it comes to being a transport mechanism, but its client libraries are, in my opinion, significantly less elegant in how they're implemented than MassTransit is. And MassTransit has support for Azure Service Bus as a transport mechanism. So I could have done this same demo with MassTransit, with it using Azure Service Bus for the transport mechanism and persistence of subscriptions for us. And that would have worked perfectly well. So in that particular case of Azure Service Bus, I don't think that there's an actual tyranny of the or there. If, on the other hand, you're looking at fully baked and solutions like, oh, hey, how about, talk to me about, IBM's offerings in this space, or Microsoft and BizTalk, or things like that. It's like, if you have a much larger need, if you have significant concerns in the broader space of how am I going to govern all of this, or how am I going to have to report on all of this, and you're going to wind up having to significantly invest more effort into the library to be able to build those things on top of MassTransit, it might be worth the time and effort to look at one of the commercial offerings and use them. But if the need in front of you is, I want to decouple senders and receivers, and I want to have a pattern that I can use, and I don't yet have a need for everything else, then I would say this is the place to start. Start here, and don't start at Tibco, don't start at BizTalk. Start with something lightweight, driven on top of open source technologies, and get something minimal and proven before you worry about the rest of the details.
Awesome. So this will basically be our last question, Tim, but it's kind of combining a few things. There was a number of questions kind of around furthering education or whatnot, and this is kind of puts it all together. There are endless sources of info related to messaging. Where do you suggest that I go to besides here to continue learning about messaging services? What are your trusted sources? There were some around books, things like that. I know you mentioned a book at the beginning.
Yep. Yeah. So let me take a moment to go back and plug this book. Seriously, this book. Start here. And absolutely start with the Enterprise Integration Patterns by Gregor Hope and Bobby Wolf. This is where I start. After that, there are excellent resources available. Obviously, big names and luminaries in this space. Udi Dahan is regularly talking about the patterns and practices in this space. Now, Udi also shills for a product, so be aware that he has a significant financial interest in recommending you to the commercial product he maintains called Service Bus. But this definitely is one of those things. And I will say that if you get plugged into the MassTransit community, Chris Patterson, who runs the MassTransit project, has been doing a lot more Twitch streaming of late, has been doing a lot of YouTube videos showing off how to use this. And so there is a YouTube channel for MassTransit. I would recommend that you go look at that as well. Their version 7 just released at the start of July and has some amazing new features in it that are certainly worth giving a look. And that is also a community that is very connected and very available. They have a Discord server for communicating, plus they're very active in answering questions on Stack Overflow. So definitely worth giving those a look as well. So if that was our last question, I do want to thank you all for coming. I have a couple of short announcements here. So as I mentioned, the library we showed off today is called MassTransit. This is some information about them. You can find them very easily by Googling MassTransit ESB or go to masstransit-project.com, and you will find out everything you ever wanted to know about this wonderful, wonderful project and how it can help you get an enterprise service bus up and running very easily. I also want to take a moment to mention that this is part of Improving's Virtual Lunch and Learn series, and that if you come back next week, you will see an introduction to React development done by my good friend Eric. So you'll definitely want to come and check that out. And then as a quick note, the code for everything you saw today is going to be at the following GitHub repo. So go to all the code. All the code is at github.com, trayburn, DEASB. Now, with that, I thank you very much. And Max, I hand it back to you.
Well, thanks, Tim. And we want to thank you guys again for attending today's Virtual Lunch and Learn with Improving. Also, like Tim was mentioning, the recording to the session will actually be up tomorrow at improving.com/virtual. We hope you guys all have a great rest of your day. And Tim, again, thank you for sharing with us.
Of course.